Once again, I welcome you to our class on Chem 101, and in this particular video, I'll be explaining gas law. This is an introduction class to gas law, and if possible, I will explain the first law that is involved, which is Boyle's law. Now, listen. The behavior of gases, I repeat, the behavior of gases is described by gas law. So this gas law you see here, a question might come from this very angle in your exam. This gas law you see does not explain, I said the behavior of gases is described as gas law. So gas law does not explain the behavior of gases. It only predicts how gases act under usual condition. So gas law does not explain, but it predicts. So if a question should come from this very angle, I believe you can tackle it. I repeat, the behavior of gases is described as gas law. Gas law does not explain how gases act under usual condition, but it predicts how gases act under what? Usual condition. So we have under the gas law, we have Boyle's law, we have Sharp's law, we have Avogadro's, we have Graham's law of diffusion and effusion, we have general gas equation and the rest. So they are much. But for the sake of this very video, I'll say explain on, but for this episode, I will explain just the first one, which is Boyle's law. Probably in our next episode, I'll be explaining more and more and more and more. So let's get started. Boyle's law, it shows the relationship between pressure and volume. This and another examination question. Dash law shows the relationship between pressure and volume. The answer is what? Boyle's law. And Boyle's law states that the pressure of a fixed mass of a gas, the volume of a fixed mass of a gas is inversely proportional to the pressure. Or this can also be written as the pressure is inversely proportional to its volume. We are still going to get the same thing. Then remember, mathematically, if I want to remove this proportionality sign, I will introduce a constant, that is V is equals to K all over P. So K is now the constant. And making K the surrogate of the formula, I'll have PV, which is cross multiplying, is equals to what? K. Please take note. This value of K differs from the one of Boyle's law. We have a K in Boyle's law, we have a K in Sharp's law, we have a K in Avogadro, we have a K in this, we have a K in that. But for this particular episode, the K in Boyle's law differs from the K in Sharp's law, differs from the K in Avogadro's law, differs from all the K's. So please take note of that. The K here differs, and the unit, the value of this K here is joules. This is another examination question. So what is the value of K for Boyle? Please, the answer is what? Is joule. So Boyle's law is measured, which is this PV here, is measured in joule. And like what I always say, if is PV is equals to K, I can say K is equals to K. That's to say, if this part of the board is equals to this part of the board, I can equally say this part of the board is equals to this part of the board. So we can say K is equals to say K, or PV is equals to what? PV. So we can easily put, when we have initial pressure, final pressure and the rest, we can put P1, V1, P2, V2, where our P1 will be our initial pressure, our V1 will be our initial volume, P2 will be our final volume, our final pressure, right? While P2 will be our final pressure. But there's something that is very, very important I want you to know in this particular episode, talking about how you can calculate Boyle's law and Sharp's law, most especially Boyle's law rather. Now, for an inverse variation, if it is inverse variation, which is having something like this, let's say V is inversely proportional to P. Anyhow, if you're having an inverse variation, it tells you that whenever V increases, the value of P will decrease. I repeat, if the value of P is increasing, the value of V will decrease. So that is for Boyle's law. So for any calculation at all you are doing in Boyle's law, provided the volume is increasing, the pressure will definitely decrease. And if the pressure increases, the volume of the fixed mass of the gas will definitely decrease. Both of them can never go simultaneously. One have to decrease for the other one to do what? To increase. Now let's continue with our class. The next one we'll be dealing with here is the graphical representation of Boyle's law. Graphical representation of Boyle's law. Figure A, Figure B, Figure C, and Figure D. They are all graphical representation of Boyle's law. So let me explain this very one here. For the vertical axis, we have volume, while for the horizontal axis, we have the reciprocal of P, which is of pressure. Here we have log V and log P. We have PV here and we have P. Then here we have volume and we have what? Pressure here. Now, for this, let me show you something here. Let's work with a graph. Here is 0, here is 1. Let me give space. Here is 1, here is 2, here is 3, here is 4. Here is 1, here is 2, here is 3, and here is 4. Remember, here is V, while here is the inverse of P, the reciprocal of pressure. So here is telling us that V is inversely proportional to pressure. That's what this whole graph is trying to explain. Vertical axis is P, horizontal axis is reciprocal pressure, but that's not what I'm after now. Now look up. For this particular value, it tells you that when P increases, when the volume increases, the reciprocal of the pressure will as well do what? Increase. So that's to say, if P is 1, if V is 1, the reciprocal of pressure will be 1. So you have something like this. Let's trace it. P is 1, the reciprocal of pressure will be 1, so they will be somewhere here. Then if V is 2, reciprocal of pressure will be 2, so they are increasing the same way. V is 3, here we also increase to 3. P is 4, here we also increase to what? To 4. So if you want to have a graph, you now have something like this, a VT graph. So this kind of graph is telling us that for any increase in V, the reciprocal of it will take that same increase. So that's when you are going to have this kind of graph. So remember, this figure A represents for every value of, if V increases, the reciprocal of P will also do what? Increases. And if V decreases, the reciprocal of the pressure will also do what? Decrease. So please take note of that. Then for our second figure, which is second graph, is telling us that if log V, okay, let me explain first before we go to the graph. The second volume here, the second figure is telling us that if log V increases, log P will decrease. And if log P decreases, log V will do what? Will increase. So that's it. The highest value for V here, let's say, is 4. While for P, here is log V, while here will now be log P. So if log V is 4, that's to say log P here will be 1. So you have something like log P is 1, log V is 4. You have something like this. Then if log V decreases, what will happen to log P? Log P will increase. So if log P decreases, log V decreases to 3, log P will increase to what? To 2. Log V decreases to 2, log P will decrease to what? To 3. And if this decreases, let me make sure I'm drawing the correct one. Yes. Okay. If V decreases to 2, then P will increase to what? To 4. So you have something here like this. Then at the end, you are going to come across a graph like this. So for every increase in log V will lead to a decrease in where? In log P. So vice versa, we cannot say log V increases, then log P will do what? Decreases. And if log V decreases, log P will do what? Will increase. So please take note of this graphical representation. Then for this very value here, it's telling us that for any given value of pressure, for any given value of P, PV is always constant. So that's to say, let's assume that PV is 1, or let's just say it's 3. If the pressure is 1, PV will be 3. If I increase the pressure to 2, PV will be 3. If I increase the pressure to 3, PV will be 3. If I increase the pressure to 4, PV will also be what? With 3. So you now have something like this. That's exactly what this graph is trying to tell us. So if P increases, PV is constant. And if P decreases, PV is equal to what? Constant. So please take note of that. Why for this very one here, this is even the main graph talking about volume and pressure. So let me explain that quickly before we dive into the calculation. If you look at this graphical representation closely, it's telling you that when V decreases, P will increase. I repeat, P decreases, V increases, V will decrease. And if P decreases, our volume will do what? Will increase. It's talking about an inverse variation. This is an inverse variation. So that's to say, if the value of P is 4, before I write the 4, the value of, if the value of V is 4, the value of P will be 0.1. So you have something like that here. If the value of V, let's say, is 4.5, 3.5 rather, 3.5 will not be here. The value of P here will be 1 point, let's say 0.5. So 0.5 will not be at the mid. Yes. If the value of V is 3, then here will be 1. Let's say here will be 1. Then if the value of V is 3.5, here will be, let's say, 1.1. So you have something like that. So if it is 2.2, here will be, let's say, 1.5. So you have something like that. That's how you are going to have your graph. Then the graph will now look like something like this. So this one is telling you that V will be decreasing, whereby P will be doing what? Will be increasing. But please take note, they are not decreasing or increasing at the same rate. This one can decrease by 5, while this one might increase by what? By 6, or it might even increase by 1. So they might not be increasing or decreasing at the same rate, unlike the log V and the log P. So these are the graphical representation of Boyle's law. Like what I said before, for every increase in V will lead to the increase in reciprocal of P. Log V will decrease, log P will increase. For any value of P, PV is constant. Why this one is telling us that V decreases, the pressure will do what? Will increase. So that is for graphical representation of Boyle's law. Let me quickly give you one equation then. Now let me just try something like this out. Calculate the new pressure if the volume increases from 10 liter to 20 liter. That means our V1 volume increases. We have V1, we have V2, we have P1, and we have what? P2. But before we start, let's write our formula. Our formula remains P1 V1 is equal to what? P2 V2. Where P1 is our initial pressure, V1 is our initial volume, P2 is our final pressure, while V2 is our final what? Volume. Now look at this closely. Calculate the new pressure. That means we are looking at the P2. If the volume increases from 10 liter to what? To 20 liter at 1 atm. Please take note. Pressure can be measured in atm, can be measured in millimeter of mercury, can as well be measured in torrent. So please, atmosphere, millimeter of mercury, and what? Torrent. So but these two, they have the same value of 760. Why this? You convert by, you know, your normal mathematics already. So now look up, class. If you have something like this and we are looking for P2, what I wanted to know is that, let's say, let me give you option A, let's say 1.5 atm, option B 1 atm, option C 0.5 atm, option D 0.7, okay, let me just make it 2.0 atm. Now if you have a question like this should be the easiest examination question so far. Like what I do tell students, sometimes because of time you don't need to solve all these your many calculations. You just, for you to be smart, you look at the question very closely, then you pick your answer. So now look at this closely. If you look at my V1 and V2, what is the relationship? What relationship do we have here? Is it increase or a decrease? So if you are moving from V1 to V2, are you increasing or decreasing? So here, if you are moving from 10 to 20, you are what? Increasing. That means you are going up, you are increasing. Then this is an inverse variation. Boyle's law is an inverse variation. So if Boyle's law is truly an inverse variation, will my pressure increase or decrease? So I told you the other time is an inverse. So since pressure is since volume is increasing, pressure will definitely what? Decrease. That's to say our answer must be less than 1. So let's check the option. Is this less than 1? No. Is this less than 1? No. Is this less than 1? Yes. Is this less than 1? No. So the only option that is less than 1 is what? 0.5. And 0.5 might be our answer. This is just a prediction. So our answer must be less than 1. So if you calculate and you realize that your answer is not less than 1, that means there is a mix up somewhere. So I want to tell you this. It's not all the time you calculate. Sometimes just for you to look at the question closely, look at the relationship, then you can easily click your answer and then walk away. So now let's try this. P1 is P1 is 1 ATM times our V1. Our V1 is 10 liter is equals to our P2. Our P2 is unknown times our V2. Our V2 is 20 liter. So let's make P2 the subject of formula by dividing both sides by 20 liters. So we have P2 is equals to 1 ATM times 10 liter all over what? 20 liter. Liter will cancel liter, 0 will cancel 0. 1 ATM times 1, we have 1 ATM. And here we have all over what? 2. This can 1 over 2 ATM can also be written as 0.5 what? ATM. So but what I'm after is that your answer must be less than what? Must be less than 1. So if you look at the relationship now, it's correct. So if the volume is increasing, the pressure will definitely what? Decrease. So that's for that. Now let me give you this. I don't know if you are confused with this, or if you are confused, feel free to drop that in the comment section. But I would love to give you an assignment. So please, I want you to solve this. Calculate the new pressure if the volume decreases from 5 liter to 3 liter at 1000 millimeter of mercury. Please, the option, all of them, they are out. So will our answer be greater than 1000, or will it be less than 1000 millimeter of mercury? Feel free to drop that in the comment section. Hope to see you in our next episode. For now, goodbye.